much, everybody, and buongiorno. How are y'all doing? Everyone awake? You awake? All right, excellent. So, like Daniel said, my name is John, and I'm the creator of Swift by Sundell. But also, like Daniel mentioned, is that most importantly, I am a developer, just like most of you here today. And being a developer, I am constantly on a journey. The developer's journey, which is an exciting one through space, time, and lots of different technologies coming up and changing all the time. So today I want to talk about that journey and how we can make the most of it as developers. Because whether we like it or not, all of us in this room here today, we are all on a journey. There we go. Perfect. This journey is quite unique and quite special. And there's a number of different reasons for that. The first reason is that if we're going to be honest with ourselves, we don't really know where we're going, right? We can pretend like, yeah, I know what technology is going to be cool in 6 months, but none of us really know. We're all just trying to figure things out as we go. And it gets even more interesting because we don't really know how we're going to reach our destination. You know, again, we can try to plan for the future, we can try to do our best, use best practices, but technologies keep changing. Think about how much technology has changed in the last 10 years, or the last 5 years, or maybe even the last couple of months. You know, we had WWDC this year introducing techniques like Swift UI, which none of us, I think, saw coming. So things are always rapidly changing. And we're going really fast. There we go. We're going really, really fast. And there's no sign of anything slowing down anytime soon. Because we don't really have any breaks. We can't say to the rest of the industry, hey, can you please stop for 6 months while I learn Swift UI? That doesn't happen because everything keeps moving and keeps moving. And it also puts kind of a little bit of a pressure on us, and it can sometimes feel a little bit stressful or chaotic because as things are moving so fast and as things are progressing, we also constantly need to fix and repair what we've already got. Bugs happen in production, we get reports from users, something is down on our server, whatever it might be, as we're moving, we also constantly need to do repairs. And then finally, what makes our journey particularly interesting is that the vehicle we're using for traveling can dramatically change at any point. Most of us started out developing, maybe for one device, and then they moved to a second one. And now a lot of developers are targeting all of Apple's platforms, maybe even server-side, and so much more. So there's so many things going on. And I think that one keyword here among all of these characteristics of our developer journey is this last one here, change. Things are always changing, and things will probably always continue to change. And that word is an interesting one, change, because it means so many different things to so many different people. Some people, they are happy about change. They love it. They get excited by it. Some people, they're a little bit scared of change, or maybe they're a little bit hesitant, or they feel a little bit awkward when things are changing. And that's fine. And some people, they just try to play it cool. But regardless how you feel about change, is that it's kind of the only constant in our industry. So today, I want to talk about a few different things. The first thing I want to talk about is how we can deal with change and changes that happen in the tools we use and the systems that we use to build our apps. I want to talk about how we can find time for learning and experimentation and how I believe that's incredibly important for every developer. I also want to talk about how we can prepare, but not over-prepare for the future. And then finally, putting all of these things together, how they can help us improve and progress as developers. So let's dive right in and talk about change. Because there are so many different sources of change that can happen within our projects, within our teams, and within our personal lives as well. We're going to stick to the technical side for this talk, and let's kick it off by talking about platform changes. Every single year, we here have WWDC, and WWDC is an exciting time for us. It's almost like an Apple developer holiday. But it can also be a time where our world is kind of turned upside down, or like Apple liked to put it this year, blowing our minds. And there's a couple of different things that can happen. The first thing that is almost guaranteed to happen every year is that we need to migrate to a new version of our SDKs and a new Swift version as well. And that's starting to happen even multiple times per year as well now. And these platform changes, they are mostly unavoidable. We can't really put them off for too long. We might be able to stick to an older version of Xcode, maybe for a few months or maybe a year maximum, but often we really have to move along if we want to keep shipping our apps. But even though these changes are mostly unavoidable, we can usually often identify a minimum number of changes that we might need to do in order to keep our app functionally intact. I think there's a common desire whenever you're changing your tools or you're upgrading your Swift version or you have a new version of iOS come out to radically change things. But I think in order to be able to have a smooth, nice developer journey, we need to focus on decoupling feature additions and changes in tools. Because we can migrate to new tools and new versions without having to rapidly change everything at once. So how do I personally do that? Well, here's my kind of formula that I follow whenever I migrate to a new SDK or a new Swift version. The very first thing I do is I make sure that I have a clean slate in my version control. I check out a new branch, and then I use that branch with no other changes to run the Xcode migrator. I can also use some other automation or other tools. I might need to make some manual changes as well because no tools are perfect. But then once I have my app up and running, it's building, and it works, I check what the code paths are that need to be changed in order to perform this migration. And I use git diff for that. So I look in the version control what the difference is between the previous version and the new version. And then here's what's really important, is that I don't just directly commit that. I don't put it as a pull request on GitHub and say, OK, that's done, calling it a day. Instead, what I do is I go through these code paths, and I make sure that these code paths have tests. I know that not everybody is super into the whole test-driven development and always testing everything, but having automated tests just for the code paths that are affected by a migration can be an incredibly life-saving thing when it comes to avoiding bugs, avoiding regressions, and really making the whole process so much smoother. Then when I've make sure that those tests are in place, I perform and commit the migration. But what's really key here is that I really only perform the minimum amount of changes so that I can then move on and do more larger changes going forward. So those are migrating to new SDK versions, but there's also always a lot of new system features and frameworks and things like that we want to adopt. Now, sometimes we might feel that we always need to adopt all of these features immediately. But the fact is that most of them are opt-in, and it's possible to adopt them gradually. I think a very common thought in the iOS community right now is that everyone needs to get on Swift UI right now. If you are not already a Swift UI master, it's already too late. But that's not how it works. Things are changing fast, and new things are coming, but we can gradually adopt them. And it's often possible even to take our existing code and make that compatible with all the new APIs by either extending that code or writing some form of bridging. And that way we can keep our old code, we don't have to throw it away, and still make it work in the new world. And even cooler is that it's also usually possible to adopt new APIs while still gracefully falling back to old ones, so we can keep shipping our app on older operating systems while still using the good, cool new stuff. So let's take a look at 2 examples of those kind of things. The first thing I want to take a look at is dark mode. That's a very common thing that people are adopting right now. Dark mode on iOS and macOS, and there's a very common thing where you want to use some kind of color in your app. And previously, your background color might have been white that you used in your app, but now you want to use the system color API, like the system background. And here we're using an availability check to make sure that we can still gracefully fall back on older OS versions while still using the new API. And the good thing here is that if our device is not running iOS 13 in this case, it doesn't matter if you fall back to the white color because older operating systems don't have dark mode anyway. And that's the cool thing here is that we have this backward compatible fallback. So here we can start adopting a new API through this little lightweight abstraction, and that way we can keep moving. Another example is, of course, UIKit and SwiftUI. Very, very common right now for a lot of teams around the world to want to adopt SwiftUI. And it might be tempting to rewrite your entire app in SwiftUI and throw away all of that work in code. But that's not usually a good approach. And the good news is that Apple, they really, really worked hard to make UIKit and SwiftUI work great together. So we can bridge from SwiftUI to UIKit using UI hosting controller. We can put our SwiftUI views in there. And the cool thing about that, let's say in this example here, I have a promotion view. This might be a view that we don't necessarily need to display. It only gets displayed under certain conditions for promoting some product. So we might be fine only shipping that on iOS 13 after looking at our user numbers, because it's not necessarily in the critical path of the user. And that way we can start experimenting with SwiftUI. We can, dive deeper and deeper into it and learn it before fully committing to it. And the same thing goes the other way around as well. If we have a product UI view that we want to bring into the SwiftUI world, we can easily do that using UI view representable, where we can bring our UIKit views into SwiftUI. So we don't need to rewrite our code. We can keep using it. And that, I think, is beautiful. It's actually my favorite feature of SwiftUI. There's so many cool things about it. You have the declarative nature and everything, but this backward compatibility for me is incredibly beautiful. So there are many, many different sources of change in our industry, and things are moving quickly. So some changes, like new SDKs or new Swift versions, they may be unavoidable. We need to adopt them, but we can often do it in a way that is step by step, so we don't need to do it all at once, and focusing on keeping our app intact. Also, new frameworks and system features can often be gradually adopted, so we don't need to, again, adopt them all at once. And we can often find a way to make our existing code backwards and forwards compatible. And finally, we don't need to change everything at once. By taking things slow, we can give ourselves enough time to really learn all of these new technologies before we start fully embracing them. And speaking about learning, that brings us to topic number 2. Which is all about learning, and how I think it's incredibly important for every developer to invest in both learning and experimentation. That's a big investment in yourself and in your team. Now, when it comes to learning, there are really 2 different kinds of learning that we have to do on an ongoing basis. I like to call them proactive and reactive learning. What's the difference? Well, proactive learning is when you have something you want to learn, a new framework or technique or tool or something like that that you're interested in, and you go and seek it out, you go ahead and learn it before you really have a fully baked use case for it. While reactive learning is when you need to solve a problem and you just want to learn how to solve that. You just want to learn the necessary skills to get your work done. And that type of learning, I would say, is by far the most popular one, or the most common one, when we have some problem we want to solve. Because the fact of the matter is that even though we might be really curious, and as developers we want to learn new things, sometimes we have time for that. But very often, we just want to get things done. We just have features to ship, bugs to fix, and we need to move on and keep going. So when we look at different ways we can obtain knowledge and learn new things, there are so many different ways we can go about it, and they all require different amounts of time. And if we start looking at the perhaps quickest one and very, very common way of obtaining knowledge, I think we all know what way this is. We go and open our browser, we search, and we copy some code from the internet, right? There's no shame in that. I mean, always check the license, of course, but sometimes we just need to get things done. And if someone already solved it and was willing to share it under a liberal license, then we can take that code and include it in our project. Of course, checking first that it's good and that it fits our use case. But that's very, very common, and we tend to talk about this like it's something bad. But I think it's beautiful, the fact that there's so many things out there, so many people sharing their ideas and answering questions on Stack Overflow, writing articles. It's great, like that we have all this knowledge available. But it's not the only way to obtain new knowledge. Sometimes it can also be great to read the documentation. I know it's very old school, read the documentation, but it can sometimes be really great. And sometimes the Apple documentation in particular gets a little bit of a bad reputation for being incomplete, or it's not as good as it used to be. And while the documentation sometimes, is lacking, in general I would say it's pretty good. And I think so many developers kind of dismiss the documentation just because it takes a little bit longer time to read it and find what you're looking for. And then finally, if we don't have any documentation available and we don't really want to copy something from the internet, we can always try to figure things out ourselves. We can open up some playground and try to figure it out. Now, when you look at this one-dimensional line here, it might be obvious which solution you should go for. Of course, copying code from the internet is the fastest one. Why wouldn't you do it? Well, life is not one-dimensional, so I think it's important to consider the second axis as well, which I like to call knowledge retention. If you think about it, how likely are you to remember something if you just found something on the internet, you copied it, and you entered it into your project, and you moved on? You're probably going to forget it in like 5 minutes, or maybe even 5 seconds. And while sometimes that's okay, by investing some time into reading the documentation for the tools that we use, and to actually open things up and figure them out ourselves, we can retain that knowledge so much longer. Because if we spend more time on learning something, we are way more likely to remember it, because repetition is really key. So these are the different kind of techniques that we have at our disposal and the different characteristics of them, but how to pick which one to use? Why not just, again, default to open up the web browser and search for something? Well, here's how I decide how to approach learning something new. I use this little flow chart that I made for myself, where I ask myself, is this something that I'll be able to use often? Is this some kind of knowledge that I'll be able to use going forward? For example, if it's something related to Swift UI or UI Kit or some really fundamental technology, I'll probably be able to use that in the future. But if I'm just looking to validate an email address using a regular expression, I don't know if I need to dive deeper into all those different symbols in a super long string. That's not perhaps useful. So if I don't need this knowledge in the future, I don't think, then I go ahead and I go and search the web. I find the answer and I pull it into my project. However, if I feel like this is something I could use in the future, then I want to first check if there are any official documentation on it. And if there is, I dive in and I read that documentation. Because that way I can more solidify that knowledge so that I'll be able to use it more in the future. And I might even learn something unexpected. Now, if there aren't any docs, rather than, again, directly going to the web and searching for it, I instead try to figure things out myself for about 30 minutes to 1 hour. Not a whole day, not like 5 days, just a small amount of time in order to try to figure things out myself. And even though 1 hour might seem like a long time, think about how often everyone in this room spends on 1 hour on solving a bug or being in a meeting or something else, reading emails. 1 hour in the grand scheme of things is not that much, and I think it's worth investing it in our own knowledge. So in order to do that, I use tools like Swift Playgrounds or just a brand new Xcode project. If there's some open source code I can read, I read that source code. And if I'm dealing with a closed source project like Apple's SDKs, you can always take a look at the headers in Xcode. And they can give you lots of valuable information about different APIs and maybe even some private variables that could tell you how things are stored. Or you might even see some comments in there that are not part of the documentation. Now, this middle one here, the source code one, I want to point out specifically. I think it's a very, very missed opportunity in general to read source code that is open source. There's millions and millions of lines of Swift code on GitHub that people have written where they have solved problems that you probably have faced and yet you're facing. And why not use that resource? It's such a great resource. You can learn from it, you can find out different patterns, and there's great search features as well. So this is kind of how I approach this. But what's also important to point out is that you're not always going to be able to figure things out. And that's fine. It doesn't mean that you're bad. It doesn't mean that you failed. It just means that you need some help. And that's fine. So then I go back and I get some help from our good friend, the internet. And this is kind of the flow chart I use to make sure I have a good balance between learning things and getting things done. So this was reactive learning now, reacting to immediate demand in knowledge. But what about proactive learning? What about getting some time in order to actually learn something new and to improve our skills? How can we do that? Well, I like to use 3 different things in order to make this happen. And I call them the 3 Fs. And the first F, it stands for focus. I want to make sure to have dedicated, focused time for learning, using tools that help me stay focused and it helps me explore a given topic. So I already talked about Swift Playgrounds. We can use all sorts of different tools in order to stay focused. And I think an important thing here is to have that dedicated time where rather than getting distracted, reading emails, and doing all sorts of things, we focus on learning at that particular point. The next F stands for fun. To have some fun and experiment with new tools and techniques in order to satisfy our own curiosity. Because sometimes learning something can be really, really fun. And then the last F stands for follow-up, where in order to learn something, I need to repeat it. I can't just learn it once. And one tip that I have is for everyone here at this conference is to pick 2 or 3 things that you learn during this conference and then try to repeat them over the next couple of weeks. I think that way you will learn those things so much nicer. So number 2 is all about investing in learning and experimentation. And the key here really is to schedule regular dedicated time for learning as a way to invest in your own and your team's skills and abilities. And also to treat it like work time. And when we're learning reactively, to not always go for the easy approach to search the internet, but rather to find a nice balance between just quickly finding a solution and learning new skills over time. And then finally, to use learning and experimentation proactively, because that can be a great way to prepare for the future, using focus, fun, and follow-up. And speaking about the future, let's talk about that next. And let's talk about how we as developers can try to prepare for the future. Now, preparing for the future can be super difficult because who knows what's going to happen? We barely know what's going to happen in the next couple of months, yet alone the next years or so. And since no one can really tell what the future will end up holding, all we can really do is to prepare for some form of change. Because if there's something we know from the past, is that things will keep changing all the time. And what are some ways that we can do that? Well, I think one key thing to use when we want to prepare for any form of change is to use abstractions. Now, abstractions is not only fundamental to good architecture and system design, it's also a great way to prepare for what to come. Now, abstractions is a way to decouple our code into individual, clearly separated parts, and to do that by designing thoughtful APIs. But there's a little bit of a danger here. Whenever we're working with abstractions, there's a way to both under-abstract something, to have too few abstractions, and to over-abstract something, to make it too complicated. And the trick here is really to find a nice balance between these two extremes. So with under-abstracted code, it's very tightly coupled. You have code that is very aware of all the different parts implementation details, where things are like spaghetti together, and not the good kind of spaghetti. And things are really hard to modify because they're so intertwined and everything depends on each other, and it usually requires big rewrites in order to make things happen. And we see this all the time when companies announce that they proudly rewrote something from the ground up. Well, to me, that just sounds like they declared bankruptcy on their code base and that they needed to burn it down and start over, which in my opinion is not really a great thing. But on the other hand, we can also over-abstract things with too many abstractions. And where everything is hidden behind an abstraction and data needs to flow between multiple layers, it's really, really complicated. And things can be really hard to modify then too, because they're hard to understand and it's hard to really know how data should flow throughout the system. So neither of these two extremes are really what we're going for. We want to go somewhere in the middle. So let's take a look at a concrete example of how we can find that nice balance. So here I've written a profile view controller, and this is kind of a little bit of an example. And you can see that this profile view controller here is its own data source, which is not necessarily a bad thing, but combining it with the fact that it has networking, it sets up all these views from scratch, it just uses UI view, it sets everything up, all the constraints and everything. Since it does networking, it also needs to do JSON parsing, and it needs to know about URLs. This view controller here has a ton of responsibilities, and that makes it really hard to change. Imagine trying to rewrite a part of this one to Swift UI. That would be impossible. You would have to rewrite it from scratch, which is not great. And it's also harder to maintain, harder to update things going forward, and so much more. But on the other hand, if we would take this view controller and take it to the other extreme, it might look something like this. Here we've introduced a ton of new abstractions. We've using things like generics, we have this nice presenter pattern, we have protocol-oriented programming, everybody loves that, right? We have type erasure, everybody doesn't love that, but there's type constraints here, there's all these different features of Swift being used, it looks so cool, you know, it looks almost like something you would find in the standard library. You show it to your friends and say, look, I wrote this, look how cool it is. But the thing is that even though this contains a lot of good patterns, generics are great, protocol-oriented programming can be great too, and presenter patterns, everything can be great, but mixed together like this in this very big cluster can make this view controller so much harder to work with and understand. Because we need to ask ourselves, does this really need to be generic? Does this really need to be able to accept any user type? Do we really need a user protocol? Because it's just a data model. Can't it just be simple? And that's what I think we should try to go for, simplicity. And one thing that I think sometimes get missed is that one of the absolute simplest ways to abstract data flow is to simply use functions and closures. A closure and a function just takes a value and returns a value. It's the absolute simplest abstraction. And the cool thing is that we can formalize our closures using type aliases, where we can say, this is a closure that handles a result. So it can be used as a completion handler and something like that. And the cool thing about closures is that they can be composed, which is a great sign of an abstraction, that we can take smaller pieces and build more complex pieces from them. So how we can compose a closure is we can use this kind of syntax where we can create an asynchronous closure that takes one of those result handlers from before, calls it when it's done, and that's our abstraction. Now, the cool thing about this is that it's super simple to write, and it's also super simple to use. If at our call site, we can now define any kind of user loading closure, which performs our work and then calls our completion handler. And then within our view controllers or wherever we want to use this function, we can just call it, get the result in, and handle it. A really, really simple abstraction. And likewise, for UI, I think one thing that we sometimes overlook as well as developers is that the very simplest abstraction usually for UI are simply views and view controllers. I know that a lot of developers have been burned by massive view controllers and are always reaching for different patterns. And those patterns can be great, but sometimes going back to basics might be just what we need. We can just create specialized views, like a header view or a header view controller, and then we can compose those as well. We can add views as subviews, and we can even add view controllers as child view controllers. And that way we can, again, create these building blocks where our UI is not one big blob, it's small little things that we can put together as kind of Lego pieces. So how can we now bring these two patterns back into our profile view controller to create a nice level of abstraction? Well, it might look something like this, where we have our view controller, we have our composable UI here, so we have these child view controllers that are representing the header and the list, and those can be completely isolated. We could rewrite the header in Swift UI if we wanted to, just that part, and leave the rest intact. The profile view controller would not need to be updated. We still have dependency injection, so we can use it for mocking and for testing, but we're just passing in that asynchronous closure. And if we create a little convenience method for adding a child view controller that just takes those three methods from the previous slide, we can really simply add a view controller to another one and then call our user loading closure, handle the result, and we're done. This is a fully abstracted view controller. It has all the good characteristics, but it's not using any of those really complex patterns, which I want to point out can be really great to use in certain situations, but not always. So preparing for the future is all about really trying to guess and to prepare ourselves for what might happen. And since no one can tell what will actually happen, all we can really do is prepare for some form of change to happen. And to make sure that we have clear abstractions set up so that we can individually change different building blocks of our code base and so that we can prepare for most changes. However, we also have to be careful to not over-abstract our code, to make it too complex or hard to work with, because that, ironically, can make changes even more difficult. So to summarize, how can we use all of these things that I've talked about this morning to improve and progress as developers? Well, being developers, we have to be constantly prepared for things to change, because that's really the only constant. That both involves preparing ourselves as developers through proactive and dedicated time for learning and experimentation. Try just scheduling 1 hour per week for learning. We can all spare 1 hour. and proactively learn new things. But it also involves preparing our code base by designing thoughtful and well-formed abstractions so that we can change things going forward. And while we sometimes might need to take shortcuts by looking things up on the internet or using some library that maybe does too much, but we just want this one thing, we can try to take every chance that we have to learn and improve. But most importantly of all, I think, is to remember to have fun, enjoy the ride, because that's the developer journey. Thank you so much.